Good day, everyone. So our goal is to discuss with you the expected value of a random variable. So basically, our main objective is to teach you how to find the mean, or shall I say the expected value, or the average, and the variance, and also the standard deviation of the random variable. Now we have here our definition for the expected value. It is the sum of the product of all the positive values of x and their respective relative frequencies. Now our positive value of x refers to our random values 3, 2, 1, 0 in this example. And relative frequencies are just the probabilities, okay, of the random variable. So meaning the probability of getting a random value of 3 is 1 over 10. The probability of getting a random value 2 is 6 over 10. And the probability of getting a random value 1 is 3 over 10. And the probability of getting a random value of 0 is 0. So this is what we call relative frequencies. And the positive values here are referring to the 3, 2, 1, 0, which is our random variable. Now, this is basically a probability distribution in a form of a table, no? A mass function in tabular form. Again, this is a probability distribution in a form of a table, and this is actually discussed from the alternative discussion shared from your respective SOL classroom under announcement section. Okay, now when you say expected value, we're just referring to the mean or the average or expected value in other form. No? So the mean, the average, or the expected value are just the same. And this is given by the formula EV, which stands for the expected value of our random variable x. Okay, this is just referring to the expected value, the acronym EV, or this could also be termed as the mean or the average. And the symbol, other symbol for our expected value, this is just equal to the symbol mu. So this is being read as mu. No? This is a small Greek letter coming from the Greek letter, no? Small Greek letter. So this is actually the symbol or notation for our mean, and since they are just equal, so this could also be used as your expected value symbol or notation. And this is given by the formula summation of x times the p of x. Okay, this is the formula for our expected value or the mu or the mean. Now, let us proceed with the variance. No? So for our variance, the variance is actually symbolizes with sigma square. And this is equal to the summation of the product of the square of the random value and its probability. No? So the product of the probability and the square of its random value minus the square of your mean. That is the formula for the variance. And for the standard deviation, okay, usually our standard deviation will be denoted by SD as the acronym of standard deviation, and this has a symbol as sigma. Now this is being read as sigma. It's a small Greek letter also, sigma. So this is being symbolized as sigma, and then in finding our standard deviation, this is just the square root of the variance. Square root of the variance. Okay, so these are the formula that we need to have in order to find our mean or the expected value, the variance, and the standard deviation. So if you will try to look at the probability distribution, if you will try to add all the probabilities or the relative frequencies, the probability is actually having the sum of 1, because 1 means certain to happen. No? So As you notice, the values are all positive values because your probability is greater than 0 but is less than 1. So, meaning it's between the interval 0 and 1. So, there should be no negative value of your probability. And so, if you will try to get the sum, it's always 1. Okay, so let us start with the first. Now, we have to find our expected value. So, in solving for our expected value, okay, we will be dependent to our formula. And according to here, we have to multiply the random variable or the random value, capital letter X, and its probability. So in short, on the next column, we have to multiply the two. Okay, so 3 times 1 over 10 is 3 over 10. 2 times 6 over 10 is 12 over 10. 1 times 3 over 10 will be 3 over 10. And 0 times 0 will be 0. So that would be our third column. Okay? Next, if you will try to proceed with the variance, according to here, we have to square, no? So what we are trying to complete right now in the table is the components of each formula. So we have to square our x. So squaring our random values. So this is on the fourth column. So 3 times 3 will be 9. 2 times 2 will be 4. 1 times 1 will be 1. And 0 times 0 will be 0. This is our fourth column. And according to here, we have to multiply the square of that random value and its probability. So basically, we are referring to these columns, no, from this format. So you will have the square of your random values times the probability. So we have to multiply these two columns here. So 1 over 10 times 9, that is 9 over 10. 6 over 10 times 4, so you will have 24 over 10. And then 3 over 10 times 1 will be 3 over 10. And then 0 times 0 will be 0. So this is now our fifth column. Okay, so I think we are now ready to solve for our first one, which is the expected value. Okay. Again, the expected value is just the mean or the average, and that is denoted by the symbol mu. So according to the formula, we have to get the sum, meaning we have to focus on this column because this is now the product that we are talking about, the product of the random value and its probability. And so when you say summation, you have to get the sum. So get the sum of that column. So 3 over 10 plus 12 over 10 plus 3 over 10 plus 0. But 0 is no longer understandable, that it's no longer part of the game because this is just 0. So according to the rule, if you are adding fractions and if they are having the same denominator, all you have to do is to copy that denominator and you will be adding all the numerators. So 3 plus 12, it's 15. Plus 3, this is 18. Now, 18 over 10 is divisible by what? It's divisible by 2. So this is now 9 over 5. Okay? That is now 9 over 5. So if you would like to transform this one into decimal figure, it's fine. But if you will stick to this rational figure 9 over 5, then this is still accepted. This is now your mean or your expected value. Okay, so we have here our mean is given by 9 over 5. Okay, it's time to proceed to our variance. Now again, the variance is given by the formula sigma square, and this is just the summation of the product of the product of our probability and the square of our random value minus the square of our mean. Okay, so as you notice, x squared times px is actually this column, no? The square of the random values times the probability. So we are having this column, and when you say summation, then we have to get the sum of this column. So you will have 9 over 10 plus 24 over 10 plus 3 over 10 plus 0. So see, we are adding all the values because according to here, summation. But plus 0, it's understandable that it's not part of the writing. And so, getting the sum of the values minus the square of our the mean. And our mean, when you replace that, that is 9 over 5, and you have to square that one. So, simplifying what is inside the parentheses, since we are having the same denominator, then all we have to do is to copy the denominator and then add all the numerators. 9 plus 24 is 33 plus 3, you will have 36. Minus the square of our mean, so 9 times 9 will be 81, and then 5 times 5 will be 25. Alright. Now here we are going to combine the two fractions, or we have to subtract the two fractions. And so in combining that into a single expression, we have to make use of the LCD. Now the LCD here is 50. Okay, that is the least common denominator because 25 times 2 is 50, and so when you are multiplying 10 times 5, that's 50. So 50 divided by 10 is 5 times 36. So 5 times 36, that will become 180. I want you to copy subtraction operation. 50 divided by 25 is 2 times 81, so you will have 162. So simplifying the numerator, 180 minus 162, that is 18 over 50. And what is 18 over 50? That is divisible by 2, both numerator and denominator. So your answer here will be equivalent to 9 over 25. That would be your variance. Now, 9 over 25 or 0.36, no? Or 0.36 if you will try to transform that one into decimal figure. Now, when you say variance, this is how spread the scores are from the mean, no? So, if ever in a class, if you are doing or if you did your examination and we have to add all the scores of the students divided by the total number of students, that is our mean. For the variance, it's actually how spread the scores are from the mean. So if you have a bigger value, it means to say that there are a huge spread, no, of the scores from the mean. While if you have a smaller value, it means that the values are actually closer to our mean. Okay? Now, let us proceed to the standard deviation. Now, the standard deviation, okay, let us record muna our sigma squared. So, you will have sigma squared is equal to 9 over 25. Okay, let us proceed to our standard deviation. Now, for the standard deviation, denoted as SD, this is just the square root of our variance. And as you notice, our variance denoted as sigma squared is 9 over 25. So our radicand is 9 over 25. And so according to the rule, you can give square root to the numerator and give square root to the denominator. So square root of 9 is 3. Square root of 25 is 5. Okay? So basically 3 over 5. 3 over 5, if you are going to transform that one into decimal figure, okay, you can transform this one as 0.6 in decimal figure. So our standard deviation is 3 over 5. So this is our mean, or the expected value. This is our variance, and this is our standard deviation. So this is how to find the mean, the variance, and the standard deviation given a probability distribution. Okay, consisting of the random values and its probability. Thank you everybody for listening.